Hello, welcome to session number 4 in the series Programming Languages. My name is Anurag Nigam, and we have reached session 3, in which I had discussed object-oriented programming and its 4 pillars: data encapsulation, hiding, uh, polymorphism, and inheritance. Right. So with the example, I explained that. Now let's put in more details into the core language, which is C#. And in this session, I'm going to cover two things. One is the console application. So why is console application important is that when you write classes, when you write structures, enumerations, delegates, and interfaces, right, you come to know what is under the hood when you are using a fancy desktop program with a GUI, right? So basically, a program is nothing but some algorithms which are running in the background, which you do not see, and what you see is the user interface, right? So the other aspect of Windows programming would be, or let's say Linux programming would be, the user interface, which is graphical in nature. Now in C#, there is a legacy framework which is called Windows Forms, right? So that legacy framework, Windows Forms, is like is a old technology. Later it was updated to what is called Windows Presentation Foundation. And Windows Presentation Foundation is based on a language which is very similar to XML, which is XAML, pronounced as XAML, right? So all the Windows applications, the user interfaces are done using XAML. Now again, it's like HTML, right? So in HTML there are certain tags. In XML there are tags which you yourself create, and then you validate those elements, the contents inside the tag, using some form of a schema, right? So this is something which you do in case of XML or XAML, but the major purpose for doing this is going to XAML is that you wanted desktop applications and the web applications to have a similar framework. That's what is stressed in your XAML, right, or Windows Presentation Foundation. Now, to a designer, you still do the what you see is what you get kind of a thing. So you still have some kind of a canvas which is coded in the background as XAML, and then you can still put the controls like buttons, then the various fields you can put in, like rich text box, and you can put the sliders and everything. Whatever you could do in Windows Forms, you can do in Windows Presentation Foundation, and even more, right? And you as a developer will not come to know what's underneath the hood unless you go into the depth of Windows Presentation Foundation. So that's what I am going to do. So to start with, I am going to talk about memories, data types here, right, and then operators. So this is the core C# which you are concerned with, and then I'm going to show you GUI elements. How do you make a Windows GUI using WPF or Windows Presentation Foundation? So let's go ahead, and what I'm talking about here is the software runs on a microprocessor, right? And the microprocessor has got registers, right? And when the microprocessor is running, it can only see the registers. It cannot see the other portions of memory. What are the other portions of memory? It's a memory map. And what is a memory map? A memory map is basically an addressed location which from which the data can be fed word by word into registers before they can be processed, right? So a memory map has got these registers. So registers can be a part of memory map itself, right? So memory map has got these registers with which microprocessor can directly interact. Apart from that, there is something called stack. And as soon as you say stack, this is last in first out kind of a thing. Like for example, if you have a stack of papers on your desk, the last paper you put on the stack is the first paper which comes out, right? So similarly, a stack has again been partitioned into two. One is called the program stack, and then the other is called the data stack. So data stack is nothing but like a scribbling pad where you do your rough work, while program stack is like whenever there is a interrupt, or there is a soft interrupt, right, or a event, what happens is that a function may be called or a method may be called. So whatever is the current execution, right, that details, right, have to be kept onto a stack, right? So whatever the contents of the register for the main program and where we were in the main program, so this has to be pushed onto a stack, which is a programming stack, right? And when the method or the interrupt which you call, when this is completed, you come back to your original program and start executing it. That's how mostly the processes work. So there is a data stack, there is a program stack. Now there are other memories or blocks of memories which are available. That is called a heap, right? And heap basically is under the control of a software, right? So unlike stack, okay, which is under the control of the program counters and other forms of counters, right? So that they address that locations, right? So that's a stack. But heap is purely software managed, and heap in earlier languages like for example C, you had to allocate memory and deallocate memory on your own as a programmer. And if you don't do that, then the chunks of memory get tied up, and you lose your memory. You don't have more memory for your program, right? So this has been automated in languages like C# through something called garbage collector. Garbage collector is constantly observing your memory, and whatever memory allocation is not in use, it is going to be garbage collected, or it will be placed back onto the heap, and it will be available. Now interestingly, when you say you use primitive types or primitive data types, okay, so these data types are nothing but they are classes, right? And these classes basically are instantiated into objects. So everything is an object, right, in case of C#. So whenever you talk of primitive types, they are objects, they are not variables, right? So unlike in Java, the primitive types are basically primitive types, they are not objects, right? Okay, so what are the various primitive types which we are going to see? The 8-bit primitive type is a byte. So a byte can be a positive number, so it can go from 0 to 255, right? S byte is a signed byte which can have negative as well as positive numbers, so the MSB is treated as a signed bit. That means that the lowest number can be -128 and highest number can be 127. So in all total there are 255 numbers, right? So it also uses 8 bits. Similarly character, okay, so character here is also 8-bit if it's a ASCII character, but these days to accommodate other characters of other languages like for example Chinese or Arabic, we use 2 bytes, okay, 2 bytes for a character, right? So that is called a Unicode character. So a character can be ASCII, which is 8 bits, or it can be Unicode character, which will be 16 bits, right? So that's that. Now this character is always a positive number, right? So it can go from 0 to 65536. So that 0 to 65535, sorry. Okay, so that's a character. Now integer is 32-bit, or it is going to be 4 bytes, okay? And the integer, okay, integer can be a negative or a positive number, right? And similarly there is something called uint, which is an unsigned integer. It is going to be a number from 0 to 2 raised to 32 minus 1, right? So that will be unsigned integer, and int by itself is a signed integer. Similarly, short is going to be 2 bytes or 16 bits, similar to a character, right? An unsigned short would be a unsigned number, while short can be a negative or a positive number. Similarly, long is 64-bit integer, right? So you can also call it int 64, right? So short can be int 16, int can be int 32, long can be int 64, right? So it uses 64 bits or 8 bytes to store a number. Again, the long can be a negative or positive, but unsigned long or ulong is going to be always positive. So this is about integer kind of a data type. Now the other type is the Boolean. Now Boolean in C is basically 0 is treated as false, and anything other than 0 is treated as true, but it's not so here. Boolean here is kind of an enumeration which can take two values, either true or false. That's it. So only two values are possible here in Boolean. Now other than that, there is something called float, right? And float uses 4 bytes, right? And then it has got characteristic and mantissa, right? And an exponent. That means that it has got numbers before the decimal, numbers after the decimal, and then numbers raised to something, 10 raised to something, right? So these are called floating point numbers. Now when you say CLS compliant, float is not CLS compliant. So what do you mean by CLS compliant? So attribute based programming, which I talked about in session 1, I'm talking about the same thing. So when a float is internal to an assembly, right, that would be CLS compliant. But if the float is used for exchanging something, right, so then that code which exchanges float as an input or an output variable, that will not be CLS compliant, right? So float is not CLS compliant if it is used for exchange of information, but if it is internal to a block of code, then that block of code will be CLS compliant. Now when it comes to double is same as float, but it uses 8 bytes or 64 bits, so that's a double. Now decimal basically is going to be 128 bits, and decimal is basically a creation in a workspace, and mostly it is used for financial applications, because when you deal in large numbers, then even those cents and pennies and things like that, which are very small in number, but they can, for thousands of millions of users, that they can grow to a large number. So that's why the accuracy which is required for this currency manipulation is usually done in decimal, which is a 128-bit number, similar to double, but it is much bigger. Now you have to refer to a separate namespace for using decimal, but in your .NET 6 or .NET Core 6.0, right, onwards, this is automatically handled by a piece of code which analyzes what you are going to use, and accordingly places a link to a namespace. So decimal, earlier you had to specify using certain namespace, but now you can just write it and it'll analyze your code, and it'll itself put the link to the assembly which is required. So that is about decimal. Now string, str, okay, string is just like an array, okay, an array of characters. Now a string usually ends in a null character, so basically the length of the string is always 1 plus the number of characters in a string, and string is stored in heap, okay, where most of the objects which are serialized, they are also stored on a heap. String is also stored on a heap, but then there is a portion of heap which is called string pool, where this string is stored. Now the string is usually addressed by the first element of the string or the first character. Okay, it's similar to arrays, right? Arrays is by value. So whenever you pass an array, a copy of array is created. So it's always passed by value. while a string is always passed by the reference. So basically this is a by reference variable. So it always points to the first character in the string. Now the address of the string is stored in the stack, but the string itself is stored in the string pool in heap, right? So a string is, another property of string is that string is immutable. What it means is that once you have fixed the size of a string, then you cannot alter the size of the string, or you cannot alter the content of the string. So what do you mean by alter the content of the string? So for example, if I have a string which is called California, for example, now if I change that string to be New York, then it is not possible. It has to be garbage collected, and the new string has to be created. So basically string is immutable. That means that you cannot modify a string. You have to get rid of all the things in a string and create a new string. So that is what I mean by immutable. Second thing is, when you grow a string, the way the string grows is it grows to a certain size, and after that it suddenly doubles the size, right? So as you keep on writing, the string is allocated a space, but then if it exceeds a certain number of characters, the string size is doubled. So now you might only jump by one character and double the size of the string, and rest of the characters would be just empty locations, but they are just tied in that string pool to a particular string. So string is not memory efficient. So what is the alternate for that? The alternate for that is something called string builder, right? So string builders can be used instead of string. So I hope you understand, or you can read about this, what is a string or what is a string builder, and what is the advantage of using a string builder over a string. Okay, so later on we will cover that. Now apart from these variables, right, there are certain operators which work on these variables. Okay, so first of all, there are unary characters, like they are like prefixes. Like for example, you have plus and minus, so you can have a number which is plus 64 or minus 64, for example. So plus and minus is telling you the polarity of a signed integer or a signed floating point, right? So plus and leading plus and minus mean that. Now a leading plus and minus minus, they are increment and decrement unary operators. So if these are preceding a variable, then first the increment or decrement takes place, and then the updated value is utilized. So this one is always higher in priority, while if you do a post fix, like for example, if it is following the variable, like for example a plus plus, that means the value of a is used first and then it is updated. So the updated value is not involved in the expression. Okay, the current value is involved in the expression. So that you mean by postfix. Like if you do a plus plus, that means the value of a is being used before it is incremented, while if you use plus plus a, that means that the value of a is first incremented and the incremented value is used in the expression. So that is a unary character. Now prefixed plus plus minus minus have higher priority, while the postfix are going to be far below, like it will be above the logical operators. Now here there is a little difference in precedence, so this would come here. So I'll explain you what that is. This will come here. Now apart from unary operator, so now there is one thing called this tilde, which is one's complement, and there is something called not, which is a logical not or logical inversion. So for example, if there is a boolean a equal to true, then not of a will be equal to false. So this is a logical operator, right? While tilde is one's complement. So for example, if I have a nibble which is like 0 0 1 1 is 3, and if I do one's complement, which is this tilde following that, then it will be 1 1 0 0. So 0 0 1 1 becomes 1 1 0 0. So all the bits are inverted. So this is going to be a bitwise operator, right, which is going to work on a binary number. Now as far as the numbers, how they are represented, a binary number, just one second, I'll give you an example of a binary number. a binary number can be written as 0b. Okay, so this 0b has no meaning. It just says that the numbers that follow are binary and they are going to be in zeros and ones. So I can write here 0 0 1 1 and 1 1 0 0. So notice here I have separated the two nibbles, right? So for me it becomes easier to read this, and in terms of hex I can write the same number because I have separated them in nibbles. It becomes easier to write a hex number. I have to just put 0x, and then this stands for 0 3. Okay, and this stands, sorry, yeah, so I would just put here 3. So this stands for 3 and this stands for C. Okay, so I can say 0x3c. Okay, I can still have the separator. I can still have the separator. So if I have positive ABC, then I should put here positive x. Okay, so I can write this as 0 3 underscore c. Underscore is going to be removed by the compiler itself. So underscore is just for your readability. So this can be represented as 0x3c. So the same binary number is represented as a hex number. Now this hex number basically has a base of 16, right? Binary has a base of 2, hex has a base of 16. So you can refer to any digital book and they will give you some idea for what these are. Similarly, if I have a number which is like 4 6 for example and starts with a 0, then it's an octal number, which means the base is going to be 8, right? So 6 into 8 raised to 0 and 4 into 8 raised to 1, so it will be that number. So this is an octal number. Okay, so this is a number system. Okay, and we deal with numbers, and then if the base is 10, that's called a decimal number, right? Okay, so these operators can work on these. It can also work on your floats and doubles and decimals, right? So these are called the binary operators. Okay, so this is again written in precedence. So as I go from top to bottom, the precedence drops. So this one has the highest precedence and this one has the lowest precedence, right? So okay, so maybe there is a little confusion whether this should come above the assignment operators, but let's just these are something which you can always refer to a book. Okay, so this is order. B for bracket, so it's a Modbus rule. So whenever there is a precedence of these operators, whenever you do a evaluation of an expression, and the precedence is applied either from left to right or right to left, right? So mostly it is left to right. So we'll start with the highest precedence. The highest precedence is of the brackets, right? So if you place something inside the bracket, that will be evaluated first, right? And then brackets can be nested inside brackets and inside brackets. So the innermost bracket is going to be evaluated first, right? So this is bracket. O for order. Order means that it is raised to certain power, right? So that's why I'm putting this there. This is divide. Okay, so this can be a integer divide or a floating point divide, right? Usually in divisions, as far as I haven't tested it, you can test it. It is a double. So basically, even if you are dividing a integer, okay, that integer is converted to double, and then the division takes place, and then after the division it is converted back to integer, right? So by rounding off, right? So many compilers do it this way, or the compilers can just divide the integers and give the result in integer form, as it happens in C, right? So I think in C# it is everything is converted to double before any division takes place. Okay, so this is divide, and this is a multiply. So bod mass multiply. Then you have this modulus, right? A modulus basically is the remainder. So if I do a 2 by 3, then the modulus is 2, or if I do 7 by 3, then the mod will give me 1, right? So that is the precedence from left to right. Then the lower precedence is plus and minus. Okay, so addition and subtraction. Now addition is the only operator which can work on strings also. So basically, so that is referred to as overloading. right? So if you take an operator and you overload an operator, it is same as polymorphism, right? So an operator can be used with different kinds of data types, and even if you create your own types, it can also be applied to your own types or user defined types, provided you overload this operator, right? So we are going to talk about operator overloading later on. So there is a plus and minus. Then these are the bitwise left shift and right shift operations, right? So you can take a number and then left it shift it by an integer value, right? So every bit moving to the right would be a division by 2. Every bit moving to the left will be a multiplication by 2, right? So this is going to be left shift, right shift. Then there are comparisons, right? So whenever there is a branching, okay, whenever there is a branching, or let's say there is a iteration, then there are certain conditions to be verified, which branch you are going to take, or whether you want to continue with the iteration or you want to terminate the iteration. So for that you need something called comparison, right? So less than equal to, greater than equal to. So this is that, and the result of this comparison is a Boolean variable. It can be a true or a false, right? So an iteration or branching can be based on true or false, right? Now apart from that, there are bitwise operations. Like for example, I can take two numbers and I can AND them bitwise, and I can XOR them bitwise, or I can OR them bitwise. So these AND, XOR and OR operations, which are bitwise, can be used for masking, right? So whenever there are control words and you want to mask a certain bit, right, you can use these bitwise operations. Now these are called logical operations. These are logical Boolean operations. Like for example, this is called AND operation. Now if you take two Boolean variables and you AND them, right? Or if you take two Boolean variables, if you OR them, right? Now if you were to do a chaining of this Boolean variables, so for example, A AND with B, so in that case I'm using short circuited AND. So this is also called short circuited AND. So if I do A AND with B and with C, so to find out the result of this expression, it is going to first look into A. If A is 1, okay, then only it's going to check B. If A is 0, then A and B and C is always going to be 0, right? So this is called short circuited AND. So it checks the value of the first operand before it proceeds to the second operand. So in case of AND, if the first operand is itself 0, then there is no point in evaluating the chain of that expression, right? Similarly, OR, right? So it is going to check if the first variable is 1. If the first variable is 1, no matter how many variables are in there in the Boolean expression, all are ORed. For example, A ORed with B ORed with C. If A itself is 1, then it doesn't have to check for A OR with B or with C, because the result is always going to be 1. So this is called short circuited OR operation. Now again, these are called, okay, besides this, there are other variables in here, which is basically equal to and not equal to. Okay, so these are again basically comparisons only. If two variables are equal, or if the two variables are not equal. Okay, now this is interesting. In case of C, if you say one string is equal to other string, then that comparison will not work. Okay, so you cannot say that let's say if a user entered if a user, for example, entered the type of his vehicle. For example, the various types of vehicles, for example, available is bikes, motorbikes, then let's say scooters, right? So let's say a user chooses a bike, a motorbike, or a scooter from a drop down menu, and inside the program you are comparing the choice of a user. So if the choice of user is equal to bike, or motorbike. So you can compare these strings in case of C sharp, right? It is going to find out the the comparison. Okay, but in C it will not work because these are not overloaded for strings, right? Okay, so that's the basic difference you should know before you run into some kind of a logical problem. Now these are called assignment operators. So first is equal to, then this one is at the wrong place, then you have got any operator followed by equal to. So for example, if I do a plus b, b is equal to a plus b, for example, then I could have simply written, so basically b is equal to a plus b. Okay, so a is added to b and the data is stored in b. So you could have written b plus equal to a. That would be basically add a to b and store the value in b. So you have this as a assignment operator only. So minus equal to, divide equal to, multiply equal to, mod equal to. Similarly, you can also do left shift equal to, right shift equal to. You can do a logical and equal to, or equal to, XOR equal to, right, and all that. Now this one is called a ternary operator. So basically it outputs something. So there is an expression. If that expression results in a Boolean true, then the first operand is applied to. So this is wrongly written. I should have written this like this, and I'll show you what this is. Okay, so there is a Boolean which decides if it is true, then the one which is on the left side of this colon is assigned to whatever the LHS is, and if it is false, then whatever is on the right side of this colon will be assigned to the LHS. So this can be used like if statement. This is like a shorthand for the if statement. So these are the various operators which can be used with data types. Now whenever you do expressions, you have to be careful that that there is something called widening. Okay, and then there is something called narrowing. So for example, if there is a long, and if that long is converted into int, that will be called narrowing, because long is using 8 bytes and int is using 4 bytes. Now the value of long will be preserved and assigned to value of int, provided the value of the long is not exceeding what a int can hold. Otherwise there will be a wraparound. Okay, so for example, let's understand this in terms of short and int. So for example, let's say I'm assigning an int to a short, right? So int is using 4 bytes and short is using 2 bytes. The maximum value of short is going to be, or u short, the maximum value of u short is going to be 65535, right? So if int value is more than 65535, then that maximum value is subtracted, and whatever is the remaining value, it is assigned. So this is called wraparound. Now it can resort to as many wraparounds as required to fit into u short. So it's not that 65535 is subtracted once. It can be subtracted multiple times to result in a number which is smaller than 65535, and that would be assigned to u short. So whenever you do a narrowing from int to u short, that's what's going to happen. Now this narrowing is not implicit. You have to do it explicitly, which is called casting, and you will be responsible for the side effects, that is wrapping around, if you are doing casting. Okay, now in case of expressions, whenever there is an operator, okay, and then there's a binary operator, there are 2 operands, the size of the biggest operand, okay, would be the one which will be used for the smaller operand. So for example, if I was to use let's say if I was to use integer and multiply with a long, then the integer will be widened to a long before the multiplication takes place. This is called widening of integer into a long, and before the operation takes place, and this is automatically done. So this is implicit. So widening can be implicit, but then the narrowing is not implicit, right? So you have to handle your narrowing. Okay, so that's what I mean by casting, right? So either you have to handle uh, the cast, you should handle casting by yourself rather than leaving it to a compiler rule, right? So having said that, I think we have covered mostly about what is data types and what are the operators. Another thing is, for example, in int, right? Int means it's a signed number, right? While uint is an unsigned number, right? And whatever is assigned, it's like a string of numbers, right? So for example, if I say 256, so there are three numbers here, 2, 5 and 6. It's like a string of numbers, like three numbers, right? Okay, so okay, what I was trying to explain to you. Okay, so let me see if it comes to my mind again. I'll explain you what I was trying to explain. Okay, so let's say, yeah, so I was trying to go to literals. Okay, so this string 256 is assigned to, let's say, integer a. Int a equal to 256. Now 256 is called literal. Okay, now if you assign 256 to a unsigned int, okay, then the literal is an integer and it is automatically casted into a uint, right? So 256 is a literal which may be an integer because it can be a negative number also, right? But it is assigned to a uint which is a unsigned int, right? So this conversion you are expecting that the compiler will handle it. Another way of doing this is you mark the number with a u which is trailing u. So you can say 256u. That means that it is a literal which will be assigned to a uint. Okay, similarly if you say long, right? So if you say 256, okay, now this 256 cannot fit into a character, it cannot fit into a byte, right? It has to fit into an integer, but it can also fit into a what is called a long, right? So how do you know the literal is an integer or a long? So if you want to be explicit with the literals, you can say, you can add a postfix, or you can add a trailing l. L can be a lowercase or a uppercase. So I can say 256l. That means I'm assigning a long literal to a long variable. So you can also have a ul. Ul means unsigned long, right? So you can say 256 ul. That means I'm telling the compiler I'm assigning a literal which is 256, but it is an unsigned long which is assigned to a variable which is unsigned long. So literals is something which you should understand. Similarly for decimal, I can say decimal a is equal to 23.4, but 23.4 itself is just a decimal by default, is just a double by default, right? So how would a literal be called a decimal? If it is a double, the conversion can be specified to the compiler. So you add a postscript m, letter m, small or capital. Okay, so I can say 23.4 m. That means that my literal is 23.4, which is the decimal number which is being assigned to a variable which is decimal. Similarly, when you say 23.4, it is by default a double in C#. And if you were to assign it to a float, then this will be called narrowing. So if you say, okay, some float b is equal to 23.4, that means that you are assigning a double to a float. So instead, you should specify a literal as 23.4 f. F refers to a literal which is a floating point, right? So this is something about literals. So now we are very clear on what are the data types, what are the operators, right? We know where they are stored, you know, whether it's a register or a stack or a heap or a string pool, right? So this is what we are going to very quickly see. So I'm going to create a new project So here I am going to say console. So I am going to do a console, right? Next, and let's call this as lesson 4, maybe lesson 4. Let's Okay, so lesson 4, say next, and here I'm say don't use the top level statements, create. Okay, so now this is very simple. We have already seen what is the structure of a program, what is a namespace, and we have seen what is a class, and we have a method which is called main, which is static because it's a member of the class and it's a entry point. It always starts with this example hello world, which I don't want. Okay, now if this static has to consume something which is a member of a class, then that also should be declared as static. So this is static I am putting just for complying to that. Okay, so I can say static byte. Okay, and that byte is, let's say, a. Okay, now when I say a, that means that this is going to go from 0 to 255. So if I do 255, it's not going to complain. Okay, so 255 can be assigned to a. Let's see 256. Okay, as soon as I do that, I have a crooked red line which says that no, 256 is cannot be assigned to a because 256 is beyond, the storage capacity. How about -1? Answer again, it is not going to accept minus because byte is 0 to 255. It is an unsigned number. So let's say 25. So that's a valid byte. Now I can say static, I can say s byte. Now I am allowing the negative numbers. So I can put here -3, it's not going to complain. I can put here +3, it's not going to complain. Okay, but can I do 127? Yes. But can I do 128? No, because again the range is -128 to 127, right? So it will be out of the range. So 127 is fine. Now can I do -128? Yes, because this is in the range, right? Okay, now static, you have got character, and the characters are usually inside the single quotes. Like I can say single quote a. Now this is a Unicode character, but let's see if it is a Unicode. It says UTF-16, right? If it was UTF-8, then it was a ASCII character, right? So that's there. Now besides from character, I can also put here static, let's say integer, int, and let's say d. Okay, so now this is an integer and this can be a negative or a positive number. So let's put here -24. That's okay. Okay, then static int e, fine, e is equal to so let's say it was uint, unsigned int, and let's do -24. So it's not going to accept -24 because it's a negative number and this is an unsigned int, right? It has to be a positive number. Oh, similarly I can do a static short. Okay, and this short value can be can it be a negative number? No, because yeah, short is can be negative or positive. When you say u short, then it has to be unsigned, right? So it's using 2 bytes, So 65536, half of that is 3200 and what? CALC. So 65536 by 2. 32,768. Will it fit into it? No. One less than that. 32,000. Let's see this again. 32,768. Let's see if it fits in. 768. No, it doesn't fit in, right? 67 will fit in. Okay, but a negative 68 will fit in because MSB is 1. So one more negative number is possible. So that's fine. Now, if you do a static U short and you say G is equal to, then the maximum number is 65535. Okay, so that's the maximum number. The minimum number is 0. It cannot take a negative number. It cannot take a number more than this. So again, there is a crooked line. It says it's outside the range 5. And let's say, can I do a negative number? It's going to cry. Yeah, so negative number because it's a U short, right? Okay, so that said, then you have got long h equal to, now again, this is a conversion, okay, because it is going to int. You could have put u here. Similarly, this is a conversion. You could have put u here. Cannot implicitly convert u int. Sorry. Am I putting it in the wrong place? This is a u short. Okay, it is taking to integer first, so the short will not support that u literal. Okay, how about long? Okay, so let's say 34 and I put here long. That's fine. Then I can do a static u long. So this is an unsigned long, h j k l, let's say m, no, n is equal to 34 ul, right? So the literal is okay. It's complaining about l, 64-bit number. Why there is a crooked line here? What is it violating? But anyways, so these are the integer types. Now besides that, static float o is equal to, static float o is equal to 2.3. So what am I doing here? I'm trying to assign a decimal into a float. It says double precision is narrowing to a floating point number, so you have to put in here f. That's fine. So by default it is double. Static double. Now in case of this, you do not have to put this. Now what happens if I was to say static double q is equal to let's say 2? Okay, so here the widening has taken place from integer to double on its own, right? It will take place on its own. Okay, so let's remove that. Okay, so now this is about the variables. Another thing is I can say flag, so I can say Boolean, okay, or bool, and then I can say flag equal to true. Okay, so this is basically assigning a Boolean. Now can I do this? Yes, the true should become a false, right? Okay, so that's fine. So that is with Boolean. Apart from Boolean, there is string. Static string name is equal to empty string. Is that acceptable? No. So can I do string dot empty? Yes. So it clearly shows that the string is an object which has a method called empty, and what is inside an empty string? A null character. That's it. And it is given a certain length which it is not using. So if you start typing a name, for example, here I cannot assign. You can assign inside the main. I can say name is equal to Anurag Nigam, and I put here a colon. So what do you think happened under the hood? Under the hood, what happened was name was given a certain length, but then it got modified length. Then it might have scraped the previous one and created double the size. So if I am a South Indian, I can say Anurag. I can add middle names, my father name, then my village name, and then my district name, and then I keep on increasing the size of my name to any characters and still assign. Under the hood, what's happening is it is widening the string by twice the size every time it exceeds a certain number. Okay, instead I could have used a string builder. Okay, so that's about string. Okay, again, something about string is escape sequences. So for example, if I was to say this, so what do you think will happen? It will insert a new line character. So if I was to write here console dot write line, console dot write line, and if I was to print here name, and it will be done. So if I was to save this and if I was to build this, first build takes time. Okay, say 0 failed, 0 up to date, 0 skipped, and then I can go debug, start without debugging. Again, first time it's take time. Okay, so you see the escape sequence has entered a special character which is called a new line character, right? Now let's try something else. Let's try here T. So that stands for tab, right? Save. So these are called escape sequences, and I just build it, and I just debug it. So there will be a tab. So if I put two tabs, tab followed by a tab, then it will be two tabs. Tab means 8 characters in between. So it will put blank or white space 8 characters in between. So say start without debugging. So you now see the gap is widened here, right? So that's a tab. Then there is something called vertical tab. So let's put here a V. So that's a vertical tab. And if I build this solution and if I was to debug it, so it didn't accept a vertical tab. It should. Anyways, you can check the book. But let's say if I put a tag A, what is it going to do? Escape sequence A. And okay, so there was a sound. This ding ding is a sound. Okay, so can I put two sounds here? Alarm. That's the alarm. A stands for alarm. Okay, debug, start without debugging. Oh, I didn't get 2 times. I just got 1 time. Okay, anyways, so A is that alarm, and then new line, and then carriage return. So this is a return. So if I build a solution, and if I go to debug, how? Where is Anurag gone? That's kind of crazy. Carriage return first, Anyways, so that's that. What about special characters, like if I want to put a single quote? So a single quote inside a double quote has to have an escape sequence like this, and that will put single quotes around Nigam, right? So let's go ahead and build this solution and debug, start without debugging. Oh, sorry, escape sequence, it should be forward, backward slash, sorry. Okay, let's see this. Build solution, debug, start without debugging. Yeah, so it put quotes, single quotes. Similarly, I can put double quotes in here. Double quotes, double quotes. Okay, check and save. Build solution, double, so start without debugging. So now it has put double quotes, right? How about forward slash? So for example, when I say for example a location, right? So I can say C drive, and I have to put 2 times, right? C drive. So for example, let's put a location. Okay, so the location here, come on. Okay, so for example, this location, right? Come on, let's go back to that location. Copy and paste. Can't do a paste. Okay, now what's the problem with this? The problem here is that forward slash is an escape sequence. Now escape sequence R is a valid escape sequence, so it doesn't complain about that. But escape sequence L has no meaning. Escape sequence S has no meaning. Escape sequence capital N has no meaning. Had it been small n, it would be okay, because then it will treat it as a new line. But capital N has no meaning, capital U has no meaning. So if you want, you would have to type in an escape sequence for the forward slash like this. So this becomes very tedious, right? So this becomes very tedious, and you don't like this. Every time you have to hard code this path, you have to put 2 times, you have to put forward slash. Now let's go here, and if I want to correct this, I can put here a verbatim. So I can put here shift, and where is the @ sign? Yeah, so that's a verbatim string, which means that as is, the string is going to be as is. There is no special meaning of this character now. Okay, so this is called verbatim string. This basically gets rid of the headache of putting double forward slashes everywhere. So this is as whatever the string is, it's going to be as is. For example, I can print this, or I can print here Anurag, sorry, Anurag, then double quotes Nigam, double quote close. Is it complaining still? Come on, it doesn't accept that. So it means that that works only for bats. Is that so? Forward slash characters only? Yeah, maybe. So let's see this. Build, debug. So that's the path, right? Okay. Now, had I written this not as a verbatim, but as this, it would be the same thing. So insert has gone on. Okay. So forward slash. So this is forward slash. This is forward slash. Okay. Now, one of the escape sequences, it's forward slash will be, the compiler will get rid of that, and when it prints the string, it will be only with single forward slash. Build solution, debug, So you see that again the double forward backward slashes are gone, right? So that is equivalent to that. So you understand what is a verbatim string. Okay, now that's about string. What else is there? Decimal. I forgot to put in a decimal, so let's put here a decimal. Static decimal CURR is equal to M. So you see this is a very large number, but as soon as I put M, it is acceptable. So that will be assigned to a decimal. Okay, so we have covered various data types. Now we have also known what are the various operators. Now I want to show you some very basic stuff, like you know when you alter the flow of a program, right? So you use something called branching or looping or iteration, right? So I'm going to very quickly show you that. So I have to declare some things which are implementing interface which is called IEnumerable. We will come to it later on, but let's say if I have a static int and it's a array, okay, and I call this as my array is equal to, I can say new int, and then I have to provide it with a size. Okay, so this is how you declare an array. So this is a two-dimensional array which has a size of 5. It is still empty. Now how do I populate it? I'm going to use a loop or iteration for each, and then in a bracket I can say, I can either specify int a in for each int a in my array. Okay, I can say a is equal to how do I do this? Hang on, let's create here an integer, and let's that integer value be integer z is equal to 0, correct? And here I can do a plus plus z. How's that? Was it complaining? It's a iteration variable. Okay, I understand that. What is this variable called? My array. Okay, so it will be in, sorry, I was doing I was getting confused. My array, and then this will be index. So in that case I can just assign a, I don't even need z. So it will start with 0, so this is not being used. Okay, so for each int a in, or I can put I is the index. For each int I in this array, this is called iterable, iterator, sorry, and this is called iterable, right? So the iterator is int I in my array. My array I is a. So then I can go here for, I can print those values, right? For int I equal to 0, I less than my array dot length, and then I plus plus, and that's it. So now, okay, so now what I'm doing is, in using for each, I assign each element over a iterator I, right? And I assigned, what is this? Okay, I itself. Okay, so I have assigned that, and now I am displaying that below. Okay, so let's just save it. Let's just build the solution, and let's just debug it. Oh, it is not. It assigned 0. Why is it doing that? Just 1 second. For in I in my array. Huh? Am I doing something wrong here? Just 1 second. What I think what mistake I'm doing here is var I in my array this is wrong, something wrong in my interpretation. Let's say 2. Says cannot assign I because it is for each iteration variable, so that means it's a variable, right? So so if it is a iteration value, then its value should be available, right? My array I, that's the iterator, so that should be done. So everything is assigned 2 then. Let's say build solution, debug, start without debugging. So the first one is assigned 2 and the remains are not. What mistake am I doing here? Okay, let's see. Sometimes, you know, with syntax I get confused. Static, we will come to detail with this. Let's say it is a character array, and this character array is called vowels, and this vowel character array is specified as A, E, I, O, U. That's correct. So let's see what happens over here. Then for each character, CHAR, character A in vowels. Okay, and then do a console.writeLine. Console.writeLine A. Make sense? Okay, so let's see if it can iterate. This is a right candidate for this. Okay, debug, start without divide. Okay, so it writes A, E, I, O, U, and then of course the other one is 0. Okay, so let's do the assignment here. Let's read from the user and assign this into my array. So my array, I is the iterator in this case, is equal to convert to integer int 32, correct, and console.readLine. So I'm reading from the user, console.readLine, and done. So I'm reading from the user all the inputs and assigning it to my array, correct? So this is how I'm populating the array, and then I can use for each to print it out. Let's see, can I do that? For each integer a in my array console.writeLine a. Okay, let's see what happens here. Build solution. Okay, debug, start without debug. Okay, so now it's expecting some integers, 23, 45, 65. So 5 of them, for example, in this case 24, and the last one is 54. Okay, so this is what I entered, and after that it has printed 23 to 54 again. Okay, so this is how you use the for each. So you are using a iterator to iterate for each member in this. Okay, and then you're writing it out. Fine. So this is the iteration. Now there are other forms of iteration, while. Okay, and I can say here while I is less than, sorry, I is less than, while I is less than vowels dot length, vowels dot length. Okay, and then do something, and int I think is being used. Okay, so it is not there in the scope. So this is a temporary scope. As soon as the for finishes execution, this temporary variable I is gone. So in this case I have to create int I equal to 0. Right, so now I can say console, what's going on, dot write. So I'm going to use write, and here I am going to write vowels dot I plus plus, right? Vowels. So first I'm going to use that variable, and then I'm going to increment it. So in this while loop, the iterator is managed by you. So every time the loop goes through, you have to iterate, you have to update the iterator. So I'm going to update the iterator over here, right? And once I'm done with that, I can put here console dot write line a blank space. Fine. So save, build solution, and says okay. So I expected this is going to conflict with that. Okay, so this time MNOPQRST. How about T? And T less than, and T plus plus. Now it's not going to complain. Build solution, done, and debug, start without debug. So it is expecting certain numbers, 1 2 3 4 5. It is going to print them back again, and then it is printing A E I O U, right? So this is being done by the while loop. How about a do while loop? Do, and where the do while loop is going to be used. Now in case of while loop, this condition is checked at the start, and if this condition is true, then only the body of while loop is executed. Now in case of do while, the checking is done at the end. Okay, so I can say while t is iterable, I have to reassign this to, so t is less than let's say my array dot length, and here I am going to do the console dot write, control C, control V. So as soon as I come out, the t value here is going to be 5, isn't it? 1 2 3 4 5. And when I go in here, the t value is 5, which is going to be out of the range. You understand that? Right, so it should not work, right? So if I do here t minus 1, okay, so now the value 5 comes in here because the t is updated inside here up to 5 and AEIOU is printed. Now the t value comes in, so this loop is checking t less than 5 after, but this line is going to execute anyways because it is going to print the last entry in the my array, or it will be my array, right? So let's do my array. Okay, so whatever I put in my array, the last element would be printed because this while is checked at the end, and even if the t has exceeded the value or t has equaled the length of 5, still it will go inside and look for the index of 4. Okay, let's see what happens. Build solution, done, debug, start without debug. So what happened here? It's doing nothing. Okay, so it printed AEIOU. Now it is expecting me to enter numbers 23, 32, 45, 54, and 25. How's that? So 5 numbers I have entered. Then it says AEIOU, and it put the final value, which is 25, right? So if this was just t plus plus, then this is going to be in problem because now t will be here as 5 and my array 5 doesn't exist. So if I do a build solution, nothing here, but then it will give you an error on the runtime. Okay, AEIOU 23, 32, 45, 54, and 25. So it printed, and then it says unhandled expression, and this is index out of range exception because the index has gone now 5, and that 5 index is not there in my array. Close program. So with the do while you have to be careful because the condition is checked at the end, right? Now how about if I was to do here t is reset to 0? Okay, so there will be no problems now. Okay, so it will print all the values of t till it reaches t equal to 5 and it will exit. So it will print all the numbers which I entered here. Okay, so if I do a build solution and if I do a debug, okay, so AEIOU, then I enter 1, 2, 3, 4, 5. So it is going to print out 1, 2, 3, 4, 5 again, AEIOU, and then it is printing out 1, 2, 3, 4, 5, right? So you understand what is a do while loop. Okay, so besides while, do while, there is a branching now. So this was iteration. So if I say if, okay, if so let's say I get a character input from a user. How's that? So over here I can say char is equal to char cho. Okay, so this is a user character, let's say, and I say, because it's going to be a string, so I have to first convert it to a character. Okay, and here I would do a console.readline, console.readline, and I'm reading the character. Okay, so once I have read the character, I can check if, okay, I can check if the character is a if cho is equal to a, or, so just one second. Okay, sorry for the interruption. So let's go ahead. So what I'm checking here is if the character is a, that means it's true, then this condition is true. So I'm using short circuited OR, CHO. If the character is E, so it's going to check A first. So as soon as it encounters a character to be A, it is not going to check further. And if it is not A, then it's going to check E. And if it is not E, then it's going to check the next one. So this is what I mean by short circuited. Or I, then it is going to check for O, and then it is going to check for U. It's going to check for U. So the output of this will be a Boolean, which will be true if the character is one of them out in this A, E, I, O, U, and the user is going to enter that character, right? So if this is true, then I can say console dot write line, and I can say here you chose a vowel. Okay, and what's wrong with my CHOO cannot be operator? This cannot be applied to operands of type bool and character. Am I doing any oh, I did an assignment here, that's why it was complaining. Okay, so this is going to be a Boolean if you entered a vowel, and it's going to be true. Else it is going to say console dot write line, and I can put here something special which is called dollar. It's just like same as in Python, and I can say you chose a consonant, and I can put here the value of the consonant as CHO, and that's it. So it is telling you that you should have entered a vowel, one of them, but you chose a consonant CHO. So let's do this. Build solution, debug, start without debugging. So it is again asking 1 2 3 4 5, and then it's going to print that. Now here it is waiting for me to enter a character, so let's put C. So you chose a consonant C. Okay, okay, so there is a too much of clutter here. So what about I get rid of most of the stuff here? Okay, so now let's repeat this. Build solution, and so I should put here something what it is expecting. So console dot write, console dot write, not a write line, and just put here please enter a vowel, and then it's going to wait for a vowel here, and then I'm doing a console dot read line and assigning it to CHO. Save, build solution, and debug, start without debugging. So please enter a vowel. I entered A, you chose a vowel. Okay, so let's run this again. Debug, start without debugging. So please choose a vowel. I entered C, which is not a vowel. It says you chose a consonant C. So this basically is just showing the branching, right? Okay, now let's see can I do it in different way? uh, can I use a ternary operator? So I am going to say so I have read a character, then I'm going to say string, okay, and say result is equal to, okay, then I just say condition is this, then I am going to say I want this line, okay. So basically, okay, here I have to put a question mark, then I am going to go and pass on this string to result, else okay, so else semicolon, and I'm going to delete this from here onwards. So else will go away. So this string is there, and let's see if this ending correctly. So there is an error here, it should not be there. Okay, so what's happening is the result is a string, and depending on this boolean, if it is a true, then it's going to say you chose a vowel, and if it is false, then you chose a consonant. So that either of the two strings is going to be assigned depending on this boolean expression to result, and then I can say console dot write line result enter. Okay, so now I'm doing the same thing but using a ternary operator, right? So I can say save will solution, and I can say here debug start without debugging. So enter a vowel. So if I enter A, says you chose a vowel, which is doing the same thing as what if statement was doing. Now I run this again, and this time I enter C. So it says you chose a consonant C. Fine. So it is doing what if statement was doing, right? So that's how you use a ternary operator. Okay, now you can also write a ladder of statements. So I can say if CHO equal to A, sorry, let's do this. If CHO equal to A, okay, then you are going to say console dot write line, sorry, console dot write, and then you can put here you chose a vowel. Okay, and then I do this thing, else, sorry, else again if, and then again sorry about that. Okay, if this is E, console that write line. So for every whichever if statement comes true, that will be the end of the if else sequence, right? So this is like a ladder, right? So I have to just repeat this again. Control C, Control V. Okay, so then again say else if, and I can go on checking each condition. So whichever first condition turns true, that is going to exit the statement. Okay, so this time again I am going to say AE, Control C, Control V. I, then you do that. Else if control V, O, A, E, I, O, and then again I can do this. Else if CHO equal to U. Okay, so now you see this is like a ladder structure. If character is A, then do this and exit the state. If not, then do this and then exit the statement. If not, then do this, then exit the statement. If not, then do this, then exit the statement. If all the ifs are exhausted, then you say else. You can do this character, this thing, this you can print. Else console dot write line, and you are going to write line this. Okay, so this is equivalent to what I did here using ternary operator. So you see how precise a ternary operator can be. I'm doing using this now. So I'm going to run this. I'm going to say build solution, and I'm going to debug, start without debugging. Please enter. So if I enter A, so you entered a vowel. Okay, let's run this again. So now I'm going to enter B, sorry, E. So A is untrue, then it moves to the next one and checks E. Okay, now if you really want to see that whether it is doing this, I can put here the value. So let's put here $, and let's put here CHO. Okay, so I am going to print where is it the if statement is being exited. So I'll put here a $. Okay, and similarly over here a $, and a $sign here. Sorry. And another last one, a $sign here. Okay, so now it's going to point to where it is exiting. Okay, let's do this. Build solution, debug, start without debug. Okay, so it says enter a vowel. If I say enter A, you enter a vowel A. Of course, I didn't put any gap in here, so that's why it was complaining. Okay, let's look at the other one. Build solution, debug, start without debug. Okay, this time I put in E, so it says you entered E. So you can see where it exited the if statement. It exited the first condition, didn't yield a true, then it went to check the second condition, it yielded a true, then it printed the vowel which I entered, and then it exited the if statement, right? So let's do the last one. In this case is if it is a consonant C. So it says you chose a consonant C. So under else, which is the final else, it just is printing you chose a consonant C. Okay, so this is very simple now, but it is so verbose in the sense that you are using so many words to do this. Can I do it in a different way? Yeah. So let's say I read it, and let me just first write it. I can say select. Okay, and the select is switch, not select, sorry, switch on a variable which you entered. Okay, and then there's a body of switch, and say case A. okay, case A, then you are going to write you chose A, right? Console.writeLine, Control C, Control V. Okay, now once this condition is checked, if statement will exit on its own, while the switch statement is going to check further conditions below it. So if you do not want it to check the further conditions, you should put here a break out of the loop, right? So next is case E. Then I am going to just put this condition over here and put in a break. Control C, Control V, and press enter. So this indentation I can get. Okay, so it's checking AE, Control C, Control V, I. So now the two conditions cannot be saying that same. That's why it was complaining. O, U. Okay, and finally there will be default. So if none of the conditions is correct and it didn't exit, it will reach default. So once it reaches default, you'll put the final statement, which is over here. Control C, Control. And of course it is still asking for a break. Okay, so now this if statement is equivalent to this switch statement. All are branching. It's again a multiple branching. Okay, let's save this build solution. It built, and then let's say debug. It says enter vowel A, you entered A. Let's run this again. Debug, start without debug. Then I entered E, so you entered E. Now let's put the final default case. So I would say let's put in here C. C is a consonant, so you chose a consonant C. So that's the default case. So you understand what is a switch statement. Now if I was to leave it blank, then what is going to happen? For two conditions, A and E, I'm printing one statement. Okay, is it going to cry? No. So I'm going to save this. So this is called fall through. So it is falling through. So I can say build solution, and I can say debug, start without debugging. Okay, so if I enter A, it will still print E. No, it will print A, right? So if I enter A, you entered A. Okay, now I repeat this. Debug, start without debugging. If I enter E, it's going to print E. So basically this statement was all rudimentary. What I can do is I can fall through. I can use the fall through property, and I can put only one condition, one statement for all the conditions A, E, I, O, U. So it becomes so simple, right? So I'm letting this to fall through. Okay, so if it is either A, E, I, O, U, it is going to print the character. It's a vowel, otherwise it's a consonant. So you see how simple or elegant it becomes. So build solution and start without debugging. So let's say I entered here A, E, I, O, U. So let's say O. It still is going to print that. Okay, and if I print U, still it's going to print that. So if I enter U, so this is called fall through. You are falling through the case statements till you hit the statement which has a break. Okay, now can I get rid of this one too? The answer is no. So let's say delete. Is it complaining? So yeah, so what it is doing, it is not printing anything. Okay, so So you understand what this is. Okay, so the switch statement we have covered. So now these are the various iterations and branching statements in C#. Okay, besides this, I want to show you what happens in Windows applications, or how simple it is. So I'm going to close this solution, and here I'm going to make a new project. This time I'm going to say I want to do a desktop application. So it says, do you want to do Windows Forms? And this is a legacy, this is your legacy Forms. Okay, and Forms app. Okay, so basically earlier there used to be similar technology for web. They used to call it Silverlight, right? And then they used to call Forms, which you used to do using Blender kind of a software, which is basically a graphical tool to build GUIs, and the output it prints is XAML, right? In both case Silverlight and this, it was XAML only. Now you are calling it WPF application. Okay, say next, and let's say this is lesson 5, or I can say 4a. Okay, 4a, and say next, and then create. Okay, let me see if I'm recording. Yes. Okay, so here it is still writing it out. It's waiting for IntelliSense. Let it finish. So here you can see this XAML. So this is basically trying to create a window, which is the main window to start with. Okay, so that's your main window. Okay, so the XAML portion you may not look at. So for example, there is something called Dreamweaver from Adobe, which is used for writing HTML, right? And this one you can use control and then scroll mouse button to zoom in. So this is just similar to Forms only, right? So I can resize the form. What? Yeah, so I have resized the form. Okay, let's call this form, so CALC. So I'm calling this as name as calculator, and the text I put here text title. Instead of window, I call it calculator. Okay, so this is called a calculator, so it's updated here. Now usually in the application you see an icon here. So can I add an icon? So it's very simple. You go in here and you just look for CALCULA. So you can find some sites where, or you can do your own to find icon. Sorry, it should be calculator icon. Okay, so these are all icons. So if you want to use this one, for example, how about this one? What is its size? This is too big. So let's go to a website which gives you an icon. So let's say this one. Okay, so I choose a certain size of icon here. Let's say small size icon, and in this case I want to choose a very simple icon. How this one? You want to use this one? Okay, how about use this one? Right. and I can say download PNG. Is this too big? Let's go back. Different sizes. I want to use this one. Yeah, so this one I want to download. And I can say copy image, or save image, or save file as, save image as. Okay, so I am going to put this in, let's say I'm downloading it in here, save. Okay, so now where is my solution? Let's go back to this one. Okay, so if I look at this guy, where is my solution? My solution is at this location, right? Okay, at this location. So let's go to that location, Control C, and let's open a new file and Control V. Okay, and say enter. So I am in this location. I will go inside this. So I want to keep my icon here, and currently that icon is in download. Okay, so this is the icon which I have downloaded, correct? And this has to be copied inside my project folder. I'll just drag it over here. Okay, so I have an icon for this calculator, correct? So I can go here. Come on. Okay. No, I don't want to put this tag. So, okay, let's get rid of this grid. Okay, fine. Let's choose this, and this one. This one is called calculator, and icon here. So I can browse to that icon, say okay. So I have included the icon, and I can say, so it has read. I can say file, save all. Okay, now if I was to build this solution, so let's see if it is building that solution. Yeah, so it has built the solution. Then if I say start without debugging, so it has displayed this window, and it has an icon of a calculator here, right? Now I want to put here buttons 1 2 3 4 5 6, and when I press a button, I'm entering digits inside one of the fields, which can be a text box or a rich text box. So I'm entering the numbers, and then I press on an operator, and then I enter another number, and then when I press equal to, it's going to give the result. So Windows applications are so simple to do. They are just like forms. Even Windows Presentation Foundation looks to you as a programmer, what you see is what you get, right? So let's go ahead and put a button, and we will cover in detail all this stuff later on. But for now, let's say we go to the toolbox. So there is a toolbox here, and let's look for a button. There is a button here, and let's say I draw a button here. What happened to my button? Let's undo this. Button became very small. Toolbox, button, and I'm going to put my button over here. So that's my button, and that button has a name. My name, I'm going to give it is 1, and the button has a text. So content here is 1. Okay, so that's the content, and the button got sized, and I want to increase the text size so that people can read it. So let's say 48. 48 is too big. 24. How's that? So that's one of the buttons. Okay, so I can put here 1, and I can, so basically this is one of the buttons. and I can put here another button, and here I make it the same size, and this one I'm going to call 2, and the content of this is going to be 2, and the text, so it's the same size, and the text which I'm going to put here, I can put here the size of the text. Where is the text? Yeah, here. So I was using 24. Okay, so I've got 2 buttons, 1 and 2. I can put here 3, 4, 5, 6, 7, 8, 9, dot, 0, and star. Right, so I can put these buttons there. Now, how do I add functionality to do this? So when I click a button, something should happen, right? So it's very simple to program this. Choose that button and choose this one which says event handling. So we will see event handling later on when we talk about, you know, events and delegates. Okay, so let's say for now it's very simple, don't do anything. Now these are the various events which are available to you. So for example, if a mouse comes on top of it, what will you do? If so a mouse enters or mouse leaves this area, what you're going to do? If you click it, what you're going to do? So for example, if I click it, I want to write a function which is to be executed. So I will call this as show1. How's that? So as soon as I do that and click somewhere else, it has come up with event handling, and here I can put here a message box dot show, and then this is a function which will pop a message box. And what's inside a message box dot show, I can put here, so it should just one second, should show me all the overrides, right? Hang on a second. Dot show, and 11 overloads are there. So let's put here click result, okay, comma, then it says, so first is the message caption. So this one was caption, right? So this is a click result. So I'll put a message here, okay, and the message is you clicked 1. How's that? And then I am going to put here one OK button maybe. So I can put here message buttons. Okay, MESSAGE, and say buttons. Okay, message box button. Okay, and then sorry about that. Let's go back. Then say dot, and say I want an OK button. So okay, fine. So as soon as somebody clicks that button, it's going to say execute this function. And what this function is doing is it's popping a message box which says you clicked 1 as the text, and at the top it's going to say click result, and it will have an OK button. The message box displays a OK button. So what's wrong with this one? Character is not valid. Huh? What do you mean by character is not valid? Let's see why it says this leading character is not valid. Character is not valid. What am I doing here? Why does it look like this? Why it should be like a, because it doesn't look like private sub and sub. It doesn't look like C sharp. Let's undo some of the stuff. How many undos it's going to allow? It should not show up like a Visual Basic kind of stuff, right? So let's go back to my window. Okay, so what happened over here? Click button 1, click. Why does it look like this? Why does it look like VB? Maybe at the time of creation I created a VB. Well, it doesn't matter. Even if it is VB, it will still do this. Okay, so maybe I goofed up somewhere, but let's see if I can get the functionality done. Even if it is a VB, how does it matter? VB is not accepting the quote, the semicolon at the end, so that's okay. So I can put here you clicked 1, and the caption here I'm going to give is result. Okay, and then I'm going to say is message box button. Okay, so here I can put here dot okay. Okay, so maybe next time I'll be careful that I don't invoke VB. I should invoke C sharp. Okay, that's it. That doesn't matter. Save. Okay, so now if I build the project, okay, and if I debug it, so if I click this button, it pops up with this window. It says result, you clicked 1, say okay, it is missing. Click it, you can dismiss. So basically you are creating a click event, and then you are tying that click event, you are tying a method to that click event, right, using delegates. So this we will consider later on. Okay, so we will proceed slowly to this position, but if you want, you can make Windows application without knowing what's going on behind, right? Second thing I wanted to tell you is that this is creating a Visual Basic. I wanted to create here C sharp. Okay, let's see if I did it earlier. So let's close this solution and let's look for this one where I'm doing the same stuff. Okay, so let's look at its section. So this has an extension of CS. So this click event, so where is that event? Yeah, so it should be created like this, right? It says private, and this is the C sharp syntax. Okay, so I think when I'm creating the project, I created a VB WPF. I should target CS. Okay, so it's the same stuff and it runs the same way. Okay, so I'm using a different icon here. If I click this, says click action, you just click once. So okay, so this is how you create a Windows application using XAML, and if you want, you can read the XAML. Where do I read the XAML? XAML, it should be here only somewhere. Yeah, here's the XAML. Okay, so you see here, whatever I had drawn, it's added over here. It says button name is 1, content is 1, horizontal alignment, height, margin, vertical alignment. So this looks like uh, just like HTML5, right, where you put in button and then you do this kind of. So you are making your own tags here, right? So and then you are hooking up functions to run this, right? So you are hooking up. So if you look at that Windows creation, okay, so this is the initialize. So basically when you go to main, says initialize component. So when you go to initialize component, you are going to see how it is going to initialize a window. Okay, this code is all hidden from you, right? And you also see this something called partial class. So he say partial class, okay, it is extending the parent class window. Okay, it's extended by this main window, right? And then you are constructing the class. So when you construct a class, the first thing is you construct a window. So in this case you say initialize component. So basically then this is initialize component, and that's basically a container class. Okay, so it's basically creating a container with all the controls, and then it is going to basically suspend the what you call the rendering, and then it will populate the form or whatever, you know, the canvas is, with the button and other controls, and then it is going to again resume the layout, and then it is going to show that, right? So the details of this, okay, we will see later on, right? So for now, this you have to don't have to look into all this. You just look into this. What you see is what you get. You can make any kind of application without knowing the details of XAML, right? Okay, so this is what you can do in Visual Studio. So I'm going to stop here. Thanks a lot. Thank you.